Welcome, curious minds. Today we're doing a deep dive into, well, time travel. It sounds like pure science fiction, doesn't it?
Right.
But what if I told you it actually has a pretty surprising, even solid foundation in physics? We're going to explore the real science behind it, the paradoxes that make your head spin, and the possibilities. It's all based on the sources you shared. And honestly, you might be shocked by how much this isn't just theory, but stuff we've actually observed.
Absolutely. And what's really, revolutionary here, the thing underpinning so much of it, is Einstein's theory of relativity. It completely changes how we think about time. It tells us time isn't this absolute clock ticking the same for everyone, everywhere.
Right.
Instead, time actually flows differently. It depends on how fast you're moving and also on the gravity you're experiencing.
That's incredible. Time isn't absolute. So let's unpack that a bit. How does that relativity actually show up? Can time literally slow down if you're moving super fast? Is that time dilation?
Exactly that, yeah. Time dilation is this phenomenon where basically for an object getting closer to the speed of light, time itself slows down. But crucially, it slows down relative to someone who's, say, stationary.
Okay.
And look, this isn't just some abstract equation. It's real. It's been experimentally confirmed.
Wow. Like how?
Well, think about the astronauts up on the International Space Station. They're whipping around the Earth pretty fast, right? So because of time dilation, both from speed and slightly less gravity, they actually age just a tiny, tiny bit slower than us down here on Earth.
Seriously,
Yep.
that actually happens.
It does. The difference is minuscule, fractions of a second over months. But it's undeniable proof. It shows that travel to the future is fundamentally allowed by the laws of physics. You wouldn't even need a classic time machine.
So what then?
You just need a really, really fast ship, get it close to light speed, ride it out, and you literally arrive in the future relative to where you started.
Okay, so reaching the future. If it's just about enough speed, that almost sounds, well, maybe not easy, but possible, right?
Technically possible, yes. Engineering challenges aside.
But, what about going the other way? Turning
Yeah.
back the clock. That's where things get really interesting and complicated. The sci-fi headaches start there.
That's putting it mildly.
Yeah.
Yeah, traveling to the past is vastly more problematic. The most famous hurdle is the grandfather paradox. Everyone's heard of it.
Explain that one.
Okay, so imagine you somehow travel back in time, and let's say you prevent your own grandparents from ever meeting each other.
Right.
Well, if they never meet, then one of your parents isn't born, which means you aren't born. But then, if you were never born, how did you travel back in time in the first place to stop them? It's a complete contradiction.
It breaks itself.
Exactly. It tears apart causality, the basic idea that causes have to happen before effects. This paradox makes changing the past seem, well, maybe logically impossible or physically impossible without, breaking reality.
Wow. Okay. So is that it then? Is past travel just impossible because of these paradoxes? Or do physicists have some mind-bending way to try and resolve this?
Well, that's the big question, isn't it? And one of the most fascinating proposals comes not from relativity, but from quantum mechanics. It's called the many worlds interpretation.
Many worlds. It's expansive.
It is. The idea, roughly, is that every time a quantum event happens with multiple possible outcomes, the universe actually splits. Each outcome happens, but in its own separate parallel reality.
Okay. Hang on. So if I go back in time,
If many worlds is correct and you went back and stopped your grandparents from meeting, you wouldn't actually erase your existence in your original timeline.
I wouldn't.
No,
Yeah.
you just create a new branch, a new parallel universe where they never met and you were never born in that timeline. Your original timeline, the one you came from, would carry on just fine, completely unchanged.
So you don't change your own past. You just hop onto a different track.
Sort of, yeah. You create a new track. It sidesteps the paradox by saying you can't change your past, only create a new one.
That is wild to think about. Okay, let's fall back to, today. With all these amazing theories floating around, where does time travel stand scientifically right now? Is anyone building a DeLorean?
Well, no. Despite how cool these ideas are, and even if they work mathematically, time travel, especially to the past, remains completely unproven, purely theoretical at this point.
Right there.
We just don't have the technology or even the understanding, really. To manipulate space-time in the extreme ways needed, like creating stable wormholes or somehow harnessing the power of black holes, is way beyond us. These concepts exist in the math, sure, but there's zero experimental evidence. No one's built anything remotely close to a working mechanism.
So future travel has some basis. We see tiny effects.
Yes, tiny effects are observed. It's consistent with relativity.
But past travel is still firmly in the realm of theory and speculation.
Precisely. It's a fascinating theoretical discussion, mathematically interesting, but it's not established science right now.
Right. So wrapping up our deep dive today, travel to the future seems scientifically possible, even subtly happening already. But hopping into the past, still tangled up in some really deep paradoxes.
Exactly. And if we connect this to the bigger picture, I mean, these theories, relativity, many worlds, they really force us to question our basic understanding of what time is. They push the absolute boundaries of, well, everything we think we know about reality itself.
It definitely stretches the mind. And who knows? As research continues, maybe what seems like fantasy today could eventually open a door we never expected. So thinking about all this, what's the one thing that really stands out to you from our discussion today?